Looking at these problems, this is just coming straight from special rights. Please understand, if you have a vertical in your problem, don't give me a decimal for your answer. In fact, the only time you can give me decimals is if I tell you to round. Okay, our standard rounding is to 3 decimals, but if I say something else, okay. By the way, no, you're not taking a quiz today. Just make sure everybody's aware of that. No quiz today. All we're doing today is practice. So, on number 1, they give you a leg. How do I move from a leg in a 45, 45, 90 to a hypotenuse? Multiply by the square root of 2. So just so that you can see the work for that, if we do 3 root 2 times root 2. What is root 2 times root 2? 2, good. And 3 times 2 is 6. What is y going to be? 45, 90, those two are the same. So far, so good? Okay. Number 2. I always, when I have this, be careful because your pictures are not going to be drawn to scale. I've got the 60 here. That means this is 30, which means that's multiplied. That's my loved side. We love that one because it makes everything else easy once we have it. So I want to find that piece. How do I go from the hypotenuse to the short leg? Divide by 2. And what is 8 divided by 2? So that makes this 45. And then if I do want to go from the short side to the long leg, what do I do? Multiply by the square root of 3. So that'll be 4 root 5 times root 3. And if you have numbers under the radical and its multiplication, you can just multiply those numbers. Insides get multiplied, outsides get multiplied. Insides gets divided, outsides get divided. So that means x is going to be 4 root 15. So far, so good for those? Like, gee, why weren't the homework problems that easy? I was like, yeah. All right. So I haven't drawn these pictures out yet specifically because a lot of people don't understand where I put things, how I come up with it. So on number 3, I have a ladder leaning against a building. So here's my building. There's the ground. I'm going to lean my ladder up against the building. Just so you know, that's the ladder. The ladder is 12 feet long. Which color, blue, green, or red, is going to be 12? Red, because that is the ladder. The ladder is 12 feet. It makes a 32-degree angle with the ground. Did they say elevation or depression in here? No, so we literally just put the angle where it says to put it. So it says 32-degree ladder and the ground. Ladder, ground. 32 degrees. How far up the building does the ladder reach? Blue or green? Blue. This is what I'm looking for. So, what I have here, I have this side, I need this side, and I'm given that angle. Which trig ratio am I going to use? Sine, because that's opposite and hypotenuse. So the sine of 32 degrees is opposite over hypotenuse. So what would go into your calculator? 12 times the sine of 32 degrees. Because I got to get the 12 out of the denominator. Can somebody give me their answer to the nearest 3 decimals? 6.359 feet. Thank you so much for the label, because if you don't have the label, I'm going to assume you mean toes. It's just weird. Okay. Any questions on number 3? All right. On number 4, we've got a ship leaving a lighthouse. So this is fun. I can draw my lighthouse. And I'm going to draw my lighthouse like this. And they've got like little swirly things coming down it because it's pretty. And it's got like a little thing here. There's my lighthouse. Don't you like my lighthouse? Yes, Miss Augsburg, your lighthouse is fabulous. It is on the edge of the water. Have fun with this, guys. Come on. And then there's a boat. Boat. Okay. It says a ship 350 feet from the lighthouse. So that means this distance down here is 350 feet, which is 40 feet tall. So that's 40 feet. We want to find the angle of depression from the top of the lighthouse to the ship. Whenever I say angle of depression or angle of elevation, what do we find? But you want to be careful because a lot of people try to put an angle of depression up in this corner. It's always off of the horizontal. So you find what I call my flat, just quicker to say than horizontal, and you put your angle there. So you can either put it at the top, or because alternate interior angles, you can actually put it right here. So I am looking for that. Does that make sense? A lot of people just want to put an angle of depression. They said from the lighthouse, so I'm going to put it up there. But that's coming off of a triangle that's looking this direction. So just alternate interior angles. Find wherever your horizontal is. One angle will be right angle. The other angle is where you put it. So which trig ratio am I using here? Boop and boop. What is that? Tangent. So I will say the tangent of x is opposite over adjacent. How do I get x? What do I type into my calculator? Not negative tangent. We call that inverse tangent. So the inverse tangent of 40 over 350. What is my angle to 3 decimals? I'm not typing it in. Y'all are. Come on. 6 point. Yeah? And then put your little degree sign up there. That's considered your words. It's a word problem. You got to have some kind of a label in this. If you don't put a degree sign, you're going to see in this class, we actually mean something completely different. So the degree signs, très important. So problem number 5, we're talking about 2 buildings being 50 meters apart. So here are my buildings, 50 meters apart. So I'm just going to make this be 50. And it says if the height of each building is 20, find the angle of elevation from the base of one building to the top of the other. So I am looking for, I'm just going to go for that angle. An elevation or depression. Again, don't get hung up on the words elevate and depress. Look up and look down. Focus on where your horizontal is and tuck your angle in there. The other one's going to be your right angle. So if this is the angle I'm looking for, 20 is the opposite, 50 is the adjacent. Which trig ratio do I use? Tangent. We use tangent a lot in these word problems. So the tangent of x is opposite over adjacent. So what do I use in my calculator? Inverse tan. And to 3 decimals, could you tell me what you get? 21.801. 1. Thank you. Yes, sir. Elevation and depression. It's always talking about when you are looking. That's standard. Looking up makes that angle. Looking down makes that angle. It's always coming off of the horizontal. Do you understand? So even if I was talking about up here, the angle of depression is the angle coming down from that. So they're alternate interiors. Okay? You have to remember, whenever you see the words elevate or depress, always find your horizontal piece and tuck your angle in there. All right, so I did not post your homework answers, so I'm not checking them right now, but I do want you guys to have them out, and I want you to check them. So I'm going to try to give everybody a chance first to look at all of your answers, and then once everybody has had a chance to check their work, then we'll answer questions. So I'm just going to scooch it up a little bit. All right, so any of those problems, 1 through 12. Yes. Number 2. Okay. So for number 2, we are given this guy. So we have a 60-degree angle up here. We have x, we have y, we have 14 root 3 over 3. One of the things that I really recommend that you guys do, especially if you're intimidated by all of those problems squished together on one sheet, just redraw out on your own piece of paper. We're limited to how much paper we can use, so you get tiny worksheets sometimes. But don't feel like you have to do all of your work in that little space. So when I have a 30, 60, 90, make sure you know which one is your 30-degree angle, because opposite that is your short side. Do not go based off of the size of the triangles. You can't assume that they're drawn to scale. So this is my shortest side. How do I move from the hypotenuse to that short side? One more time. Divide by 2. But it feels a little weird to do that. So I'm going to take 14 root 3 over 3. To divide by 2 is the same thing as multiplying by 1/2. We're just tucking another 2 in the denominator. Now, there are going to be people in here who are going to say, oh, okay, 3 times 2 is 6, and then simplify 14 over 6. Don't add to your work. Simply say 2 goes into 14 how many times? 7. So this is 7 root 3 over 3 for y. Okay? When I'm looking for x, so I have y, how do I go from the short leg to the long leg? Multiply by root 3. So I'm going to take 7 root 3 over 3. I'm going to times it by the square root of 3. Don't times top and bottom by it. That's 3 over 1, root 3 over 1. So what is root 3 times root 3? And then again, don't say 7 times 3 divided by 3. Cancel those 3's out, and your answer is 7. Okay, all too often you guys are so intent on multiplying things together when it's actually making your work a lot harder. Okay. I know there were other folks that were putting hands up for questions. Yes, sir. Number 9. Where's number 9? There's number 9. Okay. Number 9 looks pretty frightening. Just the way that you're given information. Oh, that's 30. See, didn't even draw it to scale. That's okay. That's 8. It's u root 6. That's t root 3. All right, so if that is my shorter, smaller angle, that is my shorter side. That's the one I like. That's the one I love, and that's the one they've given me this time. So I'm going to pretend this stuff is not there. Just kind of take it out of our frame of reference for a second. If I want to move from the short side to the hypotenuse, what do? And 8 times 2 is 16. If I want to move from the short side to the long leg, what do? Multiply by root 3. So that's 8 root 3. The only thing that's done now is it actually has given us, just an equation we need to solve. It's okay. No big deal. So I'm going to have 2 equations. I'm going to have a funny red tip on the tip of my pen. Did I get it? Got it. Yay. Okay. So I'm going to have 8 Root 3 is u root 6. How do I get the u by itself? Divide by root 6. So let's do that. Let's divide by root 6. Okay, so that's going to be gone. Root 3 over root 6. They're both under the square root, so let's simplify. What is 3 over 6? 1 over 2. So really now I've got 8 over the square root of 2. I need to rationalize that. How does that get rationalized? Multiply top and bottom by the square root of 2. And again, don't do too much work here. What is root 2 times root 2? 2. And you know what? 2 happens to go into 8 how many times? 4. So I have just 4 root 2 for u. And I'm going to do the exact same thing for t. How do I get the t by itself? Divide by root 3. Only I can't have a square root of 3 in the denominator, so what do? Rationalize. I love that you guys are even saying the right thing. That just makes me happy. So root 3 times root 3 is? Does 3 go into 16? Nope. So I'm just going to leave 16 root 3 over 3. Do these two simplify? Nope, because you've got one inside a radical, one outside. Okay, so try to break these problems down into 2 pieces. The first piece is just figuring out what all of your sides are. The second piece is then solving the equations. Okay. Yes, sir. Sure. I love those problems. I think those are fun. And we're going to get a couple more of those in today. 10 is a couple of triangles put together. Let's see if I can draw this. Probably not very well. So we have one triangle given a 45. We're given x. Given another triangle with 45 and 10 root 2. Problem is, the side I was given is in this triangle. I need to get to that triangle. So I'm going to work my way through. The nice thing is it is a 45, 45, 90, so it doesn't matter which side I look at. Fabian, I need you to sit up, please. How do I move from the hypotenuse to a leg? Divide by root 2. So that root 2 is now gone. So it's just 10. Now, if I want to move from that hypotenuse to a leg, what do? Divide by root 2. So I'm going to do 10 divided by the square root of 2. I'm going to rationalize that. That's going to give me 2. So what's 10 divided by 2? And 5 root 2 is my answer. Okay? All right, let's look at the back side. Again, all we're doing today is practice, so please don't freak out. Make sure for there. Leaving off the degrees, tell me you're measuring it in radans. 1 full circle in radans is 6.28. That is nothing even close to 360. Big difference. Ugh. Guy needs to go away. All right. We okay with that? I'm a scooch. Scoochie, scoochie, scoochie. See, if you don't want to draw pictures, you don't have to. You can draw boring triangles. All right, I'll scooch again. There you go. Again, the biggest thing here is when they use the terms elevation or depression, find your horizontal, find your flat, tuck your angle in there. You've got to be very careful with that. That's where the number one mistake on all of these comes from. All right? Questions? Okay, let's go back to today's notes. Just going to work some practice, and then I'm going to give you guys some practice to do on your own. So, just like that last question y'all had, I want you guys to see if you can do 1, 2, 3, and 4 together on your own. I don't care. Just do them. So here you go. Take a look at 1 and 2 for me. Sometimes you get lucky with like a problem like number 1 or 4. Sometimes you're a little unlucky. You got a problem like number 2 or 3. I'm going to zoom up a little bit on number 2 so you can look at that a little closer. So for 2, what I did is I started with 5. So that's the hypotenuse. To the short side, I cut it in half. So 5 over 2. Please don't do 2.5. Okay? Don't do decimal unless I say you can round. And then if that's 5 and 5 halves, then to move from this to the short leg, I divide by the square root of 3. Which I then have to rationalize, which is where I get 5 root 3 over 6. And then I move from the short side to the long side, I double it. And so when I times that by 2, that'll simplify again. 2 goes into 6 3 times, so 5 root 3 over 3. Okay, 1 and 2 okay? All right, let's keep going then. Let's look at 3 and 4. Again, on number 3, I went from the long leg to the short leg by dividing by the square root of 3. And then I went from the long leg to the short leg by dividing by the square root of 3. Then I went from the short leg to the hypotenuse by timesing it by 2. Ariel, if you need to, go stand in the back of the room. Stand if you need to. Are we okay on those? I think those are the hardest because you got to take your answer, do something with your answer, maybe do another thing before you actually get your answer, which is just a lot of work. What's that face for, Jacob? Did you? Oh, good. All right, so now we're going to try some word problems. I will tell you, I'm not sure why this happened, but for some reason, number 5 didn't like the degree symbols, even though the degree symbols came out perfectly on 7 and 8. I don't know why that did that. So these question marks are supposed to be degree symbols. I don't know why it did that. So I want you guys to try 5, 6, 7, 8. So looking at the pictures for each of these, let's just make sure that we're all on the same page. So that's my picture for number 5. Make sure, again, I cannot stress this enough. Elevation or depression. Find wherever your horizontal is. Off of that line, you're going to have your right angle in one spot, your elevation or depression in the other. And if you get those mixed up, it's going to be painful. Okay. And then what would you do to find the height of the building? Add those two together. So that's the picture for number 5. Okay, for the picture for number 6. Again, angle of depression, it's coming out from looking straight. So depression would be this top one, or alternate interior to put your angle down here. Okay, I think that one was probably one of the most straightforward ones. Number 7, this is what you're looking at. I don't care where you put your X or your Y, just the general setup. So the smaller angle is 38 degrees. The larger angle is 48 degrees. You put it the other way around, you're going to have a little bit of issue. Did I say 48 and it was 43? Thank you. I just wrote the wrong thing. It's all right. I will fix that. 43. What do you think I'm going to use to find the height of the statue? If I have this and this, the difference, subtract. And then the last one that I really want to look at, before I have you guys actually make sure your numbers are all correct, is besides giving you guys a seizure from shaking it so much, is problem number 8. You have to notice that it says the cars are on opposite sides of the spiral. That means you have to look right for one and you have to look left for the other. Opposite sides. I do not care. You're going to get the same thing in the end anyway. Okay? So I'll give you a second to finish up the numerical values on those, or now that you've got correct pictures, to fix them. And then we'll go over it. All right, looking at the very first problem, number 5. 5, I got 808.144 feet, or 114 feet, sorry. Number 6 was 11.874 degrees. We do those two okay? Got questions on those? Let me know. Yes, sir? You typed something into your calculator wrong then. Try it again. Did everybody else get what I got on number 6? Was that accurate? Okay. Make sure you did 12.3 over 58.5. Okay. Number 7 and 8. Seven was 18.178 feet. 8 was 166.813 feet. Questions on those? Did I get a different answer than you? Which one? 7. Okay, what did you get? 148. Let me check. So you were to have taken this minus this. Oh, yeah, I apparently just don't know how to write my numbers down. Look, it really was a 4. Oh, and you can't even see my awesome, lovely things. I had that down before. Any other questions on those? All right, I want to point something out to you. What do you see at the bottom of that worksheet? Y'all see that? Your homework problems, you have it written out in front of you right now. And you're going to be taking a quiz next class. Right now, you guys have all received a classwork. I think it's like 5, 6, 7, 8. How many problems? 8 problems? You're going to do those 8 problems. But before we get too far ahead, I want to point out something that folks, I didn't even realize when I did that worksheet that people were not remembering. And that is for problems numbers 4 and 5. For problem 4 and 5, they just gave you measurements. You have to solve the triangle. Solve the triangle means find everything that you're missing. But the thing that you need to remember is that when I do my right triangle, whichever way you draw it, the right angle is always your C. The side opposite your right angle is your side C. The other two, I don't care. As long as it matches the numbers, you'll get the same thing. So if I put A here, opposite that is side A. If I put angle B here, opposite that is side B. And so when you solve a triangle, what's true about all 3 angles in a triangle? All add up to, one more time, 180. If I give you 2 sides and you're looking for a third side of the triangle, what can you do? Pythagorean theorem. If they give you 2 sides and you need to find the angles, I don't care, pick an angle. Put your angle here and then say that's opposite and that's adjacent. Or, if you don't like that idea, put your angle over here. And that's now your opposite and that's now your adjacent. You get a pick. Dealer's choice. All right? You are welcome to move around and sit wherever you'd like, work with whomever you'd like. But ladies and gentlemen, are you listening? This needs to be turned into me by the end of class. Okay? While you are working on that, I'm going to be passing back the tests. I'll call you guys up one at a time for those.